increase our efficiency and productivity through the application of robotic simulation. What does this bring us benefit and advantages? How it works? What can we simulate? And after all, what is robotic simulation? So robotic simulation is a digital manufacturing solution that allows us to build, test, and validate a 3D manufacturing environment and to perform simulation of industrial robots. So here we are able to simulate complex robot work scenarios. We can check for interlock conditions. We can check for possible mechanical interfaces and also cycle time optimization. It's mainly used in the pre-planning phases of a project where everything can be tested and validated even within a controlled environment. And in this way, the problems can be detected in advance without impacting the real environment, and the problems with new installations are avoided. In addition, robotic simulation can also be used for existing installations. So we can, for example, create and test scenarios in order to identify possible improvement proposals. So robotic simulation is a solution for verifying and analyzing process within a 3D controlled environment where we can simulate, where we can test and validate concepts in advance without, for example, having the real system installed and working. Well, robotic simulation applications also allow us to leverage 3D product and research data. And this facilitates, for example, virtual validation, optimization, and commissioning of complex manufacturing process. And this results in a rapid market launch and high production quality. We can simulate complex robotic cells with several robots working simultaneously in assembling a product in areas with very limited space, and which would be very complicated and would take a lot of time to program these robots in the real environment. So here we make sure that we won't have any kind of collision. We will avoid accidents, and if any interface is located, all the robot's trajectory or its positioning is analyzed and adjusted while we're still in the virtual environment, avoiding costly mistakes. In this specific case, here we have a robotic cell with some robots from the ABB manufacturer working on the assembly of plasma TVs. Well, within robotic simulation applications, we can create the entire trajectory that the robot must perform, and we have all the necessary tools to design a collision-free path and optimize its cycle times. Well, and what benefits does this bring us? Here we have listed some of the benefits of robotic simulation. So for example, we can reduce modification costs and production risks through a prior analysis and immediate detection of possible problems. We can also reduce the number of building physical prototypes since we can validate them through the virtual environment. We can optimize the robot's trajectory cycle time. Here we have two situations. We can create a new trajectory already inside the simulation environment, or in some cases we can download the real robot program. We can upload it to the robot from the virtual environment and rework its trajectory within the virtual environment. And in this case, this brings us more speed in the changes and avoids possible problems in the real environment. In addition, focusing a little bit on the virtual commissioning part, we are able to validate the functioning of mechanical devices through the creation of kinematics, and to validate the PLC logic and the robot logic within the virtual environment. With all this, we obtain improvements in the production process, and we increase the quality of the process through the entire life cycle of the product. So now I have some robotic simulation software options. In this case here, these are provided by the robot manufacturer themselves. So we have a software KUKA Sim from KUKA. We have a RoboGuide from Fanuc. We have a Robot Studio from ABB, and also URSim from Universal Robots. And each of these programs allows programming only one type of robot, only the model of its manufacturer. On the other hand, we also have some universal solutions for robotic simulation. There are applications that have the ability to simulate different robots from different manufacturers at the same time within these applications. So we have, for example, the process simulate software from Siemens. We have the OMIA V6 from Dassault Systems. We have Robot Expert, also from Siemens, and Robotic from Robotic company. Here we have listed two Siemens robotic simulation softwares. Both have the same graphical interface, but the difference is in the ease of installation of Robot Expert, as it doesn't have any link to some database like in Process Simulate, but we have some limitations as the possibilities of simulation. In this case, in Robot Expert, it's only possible to simulate material handling applications and continuous process like a gluing and arc welding. And it's not possible to simulate, for example, welding operations. In this case, the Robot Expert from Siemens, it's best suited for small and medium-sized business. And in this case, Process Simulate from Siemens becoming the most complete of the Siemens platform, facing the direct competitor Domia, which are the biggest players in the market in terms of digital manufacturing platforms. We also have listed here some more recent applications. They are also universal applications. We can simulate robots from different manufacturers at the same time within these applications, and that also give us the possibility to generate the robot offline program. Here we have Visual Components software from Visual Components company. We have Octopus software from Octopus company, and Robot Master from Robot Master company. What basically differentiates them are the menus, are the graphic interface, the extensions of the mathematical models, the 3D CAD files, and some other small particularities. Now I'd like to give some examples of the main features of robotic simulation. So the applications allow us to analyze process within a 3D environment. We have the ability to create kinematics for mechanical devices, machines, grippers, opening and closing clamps, welding guns, cylinders. We are also able to create all the robots offline programming. So we can connect the virtual robot with a real robot controller, and we can parameterize its trajectory with real speeds, with real types of movements, with robot signals, with release signals, and some other parameters like gluing parameters or welding parameters. So this is the step of detailing the program before downloading and loading it to the real robot. We can also work with a virtual commissioning. It means that we can validate the robot logic and the PLC logic within a control environment is still in the planning phase. In this case, we don't affect and we don't stop the real production environment. Well, in this slide, I'll show you some examples of robotic operations. There are some possibilities such as a material handling operation, welding operation, continuous operation. In this case, I have three examples: gluing operation, arc welding operation, and deburring operation, and also painting operation. Well, here in this first example, we have a material handling operation. This is for a palletization process. And here the robot pick and place the pallets. pick and place the plate and pick and place products under the pallet. In this case, we are considering an ABB robot specific for palletization process, and we are using an universal application in this case, Process Simulate from Siemens platform. In the second case, here we have a robotic cell with some robots working on welding asset. Then here we can create our weld points on the product, and we can simulate all the robots' interlock conditions. We can find the best positioning for them so that they don't have any kind of interfaces, and we can find the best access sequence for them. In this video, we can see in detail some welding points. We can see the opening and closing movements of the welding gun, for example. Here we have all the kinematics for the fixture and for the welding guns created. Okay, on this slide we have 3 examples of continuous operations. So we have arc welding operation, we have a deburring operation, and we have a stationary gluing application. Basically, here we created some continuous paths, as the name implies. We define a start point, we define an end point, and then we create all the other locations manually or through some offsets based on the start point and the end point. In the first example, in the first video, we have an arc welding operation. In this case, we are using the OEM V6 from Dassault System, an universal solution, and for the other 2 videos, for the deburring operation and gluing operation, we are using Process Simulate from Siemens, another universal solution. Here, in this last example, we have a simulation of a painting process on the roof of a car. And in this case, we have a robot under a 7th axis with a painting gun. And here we can create, we can analyze, and we can validate the paint layers. We can adjust thickness. We can adjust the distance from the tool to the point of application. We can adjust the angle. We can see if there are sections with paint accumulation, for example. And mainly, we can also generate the robot offline program. We can export the data to the real robot. Well, now I'd like to show you some other example videos for robot offline programming and some other possibilities, such as the inclusion of a point cloud into the simulation study. What's new within the simulation environment as a direct connection to a real robot. This is a specific case with universal robot and process simulate solution, and even virtual reality. So here we enter the robots offline programming stage. This is a very important phase where we connect our robot with the real robot controller. So here we parameterize its trajectory with speeds, with types of movements, with release signals, axis configuration of the robot logic in order to export this program and load it to the real robot. We can also work with the insertion of a 3D point cloud. So this helps to save effort modeling devices or modeling static parts and other areas of the scene. We can, for example, turn things on and off for a better visualization, or check collision detection, or even take some measurements. So this functionality allows to adjust the simulation layout according to an as-built plant and to visualize the assembly process in the real plant context. Here we have another research that allows an interactive online programming of the robot with a direct connection to the robot in the simulation environment. And basically here we select the robot we want to work with in the virtual environment. We connect it directly to the IP address of the real robot. We activate the live mode, and these two robots are connected. So in this way, the simulation robots follows all the movements given to the real robot, and this functionality allows us to detect possible collisions. Since we have already modeled the entire virtual environment, we already have the entire structure and the entire work area around the robot in 3D. So this is more a way of optimizing the programming process for a creation of a material handling trajectory, for example. Finally, we also have the possibility to load a simulation study within a virtual reality environment. And with that, we can see the study in detail is still in the planning phase. Here we can, for example, teleport to any region of the layout. We can take some measurements. We can make some markings and send them to the maintenance team or some analysts or to other engineers who are working on the same project. For example, we can check dynamically collisions, for example, and this turns out to be an easier and a more intuitive way to analyze the process. Okay, so this was our webinar today. We covered a little bit what is robotic simulation, what types of current softwares are on the market today, what are the benefits, features, possible types of operations, and some other examples of possibilities within these applications. And now I'd like to say thank you, and I'll pass the voice back to you, Brian.
All right, thank you, Kawar. We'll move into the Q&A session of the presentation now. So if you have any questions, please type those into the chat box, and we'll have Kawar address them for you. So we did have a few questions come in. So Kawar, the first question we had is, what are the necessary steps and conditions to create a simulation?
Okay. As a general step, we must create and we must organize our research and a product library. Once this is done, we start the planning phase, the planning work, where we import or we create a 2D layout that will be the basis for the entire simulation study. After that, the first analysis of the layout can be carried out aesthetically, and once a robot is inserted into the study, we start checking its positioning and range. As a second step, we started the working of creating the robot's trajectory, where we analyze possible collisions, where we parameterize the robot path with speeds, with types of movements, and then we can download the robot program to upload to the real robot.
All right, thank you, Kawar. The next question we had, regarding the welding simulation example you showed, how is it possible to create the weld points within the virtual environment?
Okay, we have some possibilities depending on the application. I'll give an example using Process Simulate from Siemens. We also have some scenarios. So as a first scenario, using this application, we can, for example, create a weld point library, import, for example, a .csv file containing all the welding point locations. This is automatically. We can also, as a second scenario, insert a CAD drawing with the weld point cloud. These are generally extracted from some drawing softwares, such as NX from Siemens or CATIA from Dassault or Solid Edge, etc. And we can create a welding location under each of these points from the point cloud manually. We can also, as a third scenario, we can also create the welding points manually on the product. We just click on the desired region of the product and set this point, set this location as a weld location to get all the welding point properties. These are the possibilities.
Thank you, Cora. Another question we had come in. What other simulation software is there within the Technomatics digital manufacturing platform?
Okay, good question. Within the process simulator itself, we have an application to simulate the human resource. This is the process simulate human. There is also inside the Technomatics platform, we have a Jack software. This is a more complete software in terms of resource aimed at the ergonomic simulation, the process simulate human. So we have also Jack software. We also have inside this platform the plant simulation software. This is a discrete event simulation software. And lastly, we have robot expert software that is it's dedicated to robotic simulation, but this is exclusively for material handling and continuous operation. It has the same interface as process simulate, but this is a simplified version.